1 students, multiplying polynomials part 1. Went to see the Lego movie last night. Everything is indeed awesome. Totally worth the money. Remember Cinema Cafe, Wednesday nights, $3.50. I know a lot of parents won't take you on a weeknight, but it's worth it. I know you're like, ew, Lego movie, that's a kid's movie. It was hilarious. So, we're going to be talking about multiplying polynomials, and we're going to do this in 2 parts, kind of like we did the laws of exponents. I know that right now you probably are reading the comics, and the one on the right is cute and funny, but the one on the left, you're probably like, what? Well, this right here, you'll understand that soon enough, I promise. The next video, actually. I'm just going to have to keep you in suspense. All right, let's multiply some polynomials. So we're going to start with a distributive property review. Let me go get the problems. I've decided to put less on the PDF because you guys aren't writing anything down, or you're not writing very much down, and you're not retaining it as a result. So let me go get the image. I'll be right back. Hold on. Okay, little distributive property review. So let's remember what happens here when we distribute. We're saying 3 times the x and 3 times the plus 2. So that's 3 times x or 3x, and 3 times plus 2 or plus 6. Same thing here. 3 times x minus 2, instead of 3x plus 6, it's 3x minus 6. And the next one, now with a negative 3, you got to pay attention to your signs. So negative 3x minus 6. Negative 3x minus 6. What happens here? That's that distributing a negative. Again, we got to watch our signs. Negative 3x plus 6. Now, when we start multiplying a monomial by a polynomial in the next slide, it's very similar. It's just applying the distributive property on a much larger scale. Okay, let me get your examples for this page. And there you go. So we have example 1, x times the quantity x plus 6. So just like we did with the number, we're going to multiply. So x times x and x times plus 6. X times x, we've learned, we know x times x, that's x squared, plus x times 6, and that's 6x. So that wasn't complicated. Let's try the next one. The quiet lull between songs. Picked an interesting playlist today. I think I've played Regina Spektor before, but I just like this song, so I put it on there today. All right, a squared times 3a. So now we have to apply our product of powers rule and add those exponents. Remember the one exponent on the a by itself. So 2 plus 1, 3. So 3a to the 3rd power minus a squared times a minus or negative 4 is going to be minus 4a squared. Okay, let's do a couple of more complicated examples on the next slide. Okay, let me go get your examples. Okay, obviously these are a little bit bigger, but it's the same process as before. Let's switch colors. I want some purple. Let's see. Find a good purple color. Are you looking at the first one? So we're distributing a 5n this time. So we're going to be thinking about products of 5n and each of these terms. So 5n times 3n cubed. Well, 5 times 3, that'll be 15. And then n times n cubed. Product of powers, add the exponents, n to the 4th. Now we have 5n times a negative n squared. So that would be 5 times negative would be negative 5. N times n squared would be n to the 3rd. And then 5n times a positive 8. 5 times 8 is positive 40n. So notice that because we multiplied a 1st degree monomial by each term here, the exponents each went up by 1. It was 3, 2, 0, and now it's 4, 3, and 1, invisible 1. Awesome. All right, now watch your signs. Look at the next one. We have negative x cubed times 9x to the 4th. Well, negative 1 here times 9 is going to be negative 9. X to the 3rd times x to the 4th is x to the 3 plus 4, or 7. Again, negative x to the 3rd times minus 2 or negative 2x cubed. Minus 1 times minus 2 is plus 2. X to the 3rd times x to the 3rd is x to the 6th. And finally, negative x to the 3rd power times 7 is negative 1 times 7 is negative 7. And then just x to the third, nothing to change the exponent. Let's take a quick break from doing the multiplying, and why don't you tell me, please, what's the name of this polynomial? It's got 3 terms. Who remembers what that is? Now, I know I can't hear you, but I'll pretend that I can hear you. Trinomial, good. I heard somebody say it. And then 7th degree. Is there a name for 7th degree? No, there is not. It's a 7th degree. We don't have a special name. Just say 7th degree trinomial. How about this one? Same idea. 4th degree trinomial. Trinomial. Like polynomial, like the little gnomes in that previous video. You get that now? All right, next slide. Okay, let's talk a little bit about area models. Algebra tiles, there's some basic algebra tiles that we will use, and I have a cool app that I'll put up on the Promethean. Oops, sorry, that's kind of random thing there. I didn't mean to put that there. Okay, anyway, algebra tiles are like this. You have a square, and that represents a 1. You have a, whoops, sorry, moving the slide around. You have a rectangle, and that represents x. And then you have, oh, come on now, LeCompte. You have a much larger square, which represents x squared. So let me write that on these. This is a 1, this is an x, and this is an x squared. So if I go back and I think about the first problem we did, which was x times x minus 6, I believe. Well, what we do is we put, and I'm going to do it with the colors here, we put across one side, we put the first product, the first factor. Pretend I'm just coloring it in. So that's x, and then we multiply that by x, same size, plus 6. And we really should make that a different color, the other part. So we should make that different color. I'll make it purple. So my 1s will be a different color. So we have 1, 2, 3, 4, 5, 6. Okay, so those are my 1s. So this is x plus 6. This is x times x plus 6. And when we fill in an array, and you learned this when you took 3rd grade math, an array is where you fill in the rectangle. So we have here, we have an x squared right here, x times x, x squared. And then we have 6 times x. So 1, 2, forgive my messiness. It's hard to be neat on this app. Okay, this is a Phish song from an album called Farmhouse. Alright, and so we have it. Sorry, at least I'm coloring slightly inside the lines. But look at what we end up with. X squared plus 6x. So an area model lets us see what's happening when you multiply the two together. And it helps us recognize that we're only changing the exponent here because we multiplied x times x, and now we have the area x squared if you think about it on the area model. And then 6 times x gives you the 6x. Let's look at it with a slightly more complicated problem, because what we have to start talking about is what happens when you multiply 2 binomials. Like this. My 2 binomials here are x plus 4 and 2x plus 3. And that would look like so. X plus 4, and then the other binomial 2x plus 3. So that is a little confusing. How would that work? Well, let's look at it in terms of an area model. And let's do it in terms of our area model. Let's fill it in. Take a second. If you're not using your PDF, take a second, sketch it, and try it. This is not a long video, so I'm going to let Phish play for a minute. You just think on that. Okay, so I'm not going to give you a full minute, but, you know. Okay, so let's start filling it in. X times x, x squared. X times x again. This x over here, I dotted it. X squared. Okay, good. So far we know we have 2x squareds. What about x times 1, 2, 3? That would give me 3x. 1, 2, 3. What about over here? X, another x times 1, 2, 3, 4. Well, x times 4 would give me 4x. So we'd have 1, 2, 3, 4, and we'd have it again. So that would be a total on this side of 8 x's. But we have an empty space. we do need to fill that empty space. How do I fill that empty space? I multiply 3 times 4, which gives me an array of what? What number is that there? We know, we already said this is x squared. This is another x squared. This is 3 x's, 1, 2, 3. This is 1, 2, 3, 4, 5, 6, 7, 8. And this is 12 unit blocks, so that's a 12. So when I multiply these together, I get 2x squareds. That's right here, x squared, x squared. I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11x plus 12. Now we obviously can't use area models every time we do it, so that's why next video you're going to learn a little something called FOIL. And it has nothing to do with baked potatoes, I promise. So your third song, it wasn't the final song I put on the playlist either, which kind of makes me sad that it ended up not being long enough to play all the songs I put on your playlist. This comes from the movie Over the Hedge. This is Ben Folds. Anyway, I know, I'm talking more about the music tonight than the math. So hopefully you're comfortable multiplying polynomials, really just monomial times a polynomial. We're going to get more into this 2 binomials thing in class. Okay, guys. I will see you in class.